So acids are molecular compounds, but when you put them in water, they form ions. So sometimes it's convenient to think of them as ionic compounds. And it may sound like I'm talking about them as ionic compounds. I just want to be clear. I know that they are not ionic compounds. So in the acids that we're going to talk about, we're always going to have hydrogen as the first element, and it's going to be followed by one or more nonmetals. So we recognize acids from their formula because they start with H. So again, we're looking at the first element. If it's H now, we say, oh, that's an acid. If it's a nonmetal and there's two elements, binary molecular compound. If the first element's a metal, it's ionic. So that first element tells us a lot. And of course, there have to be two categories of acids. There are binary acids, which are hydrogen and a nonmetal, and then there's oxyacids. Guess what oxyacids have in them? Oxygen. Okay, so acids, first element has an H. Binary, only two elements, H and something else. And the oxyacids are going to be H, something else, and oxygen. So binary acids. Here's the basic pattern here. We've got hydro and a base name coming from the element name that's with it. And here we change the ending to ic, and then the last word is acid. So this is when you have two elements. So examples here, HCl. First element is hydrogen. We say that's an acid. And there's one other element, it's chlorine. So hydrochlorine becomes chloric acid. Hydrochloric acid. This tells us there's hydrogen and chlorine together. Acids are very easy to recognize from their names because they actually have the word acid in their name. That's just so nice. It's like we're throwing you a bone, right? HBr, hydrogen and bromine. Hydrobromic acid. Now, what's this business with the AQ and the G? We're not going to get hung up on this. AQ means it's dissolved in water. These compounds are technically only acids when they're dissolved in water. And so when you have HCl with G, this means the gas state. That actually refers to hydrogen chloride molecules and not to the acid. So you're going to see a lot of AQs with these acids, and that's why. Because technically, if it's not dissolved in water, it's not an acid. But we're not going to get hung up on that. Okay, so this guy, H2S. What is its name? Well, we've got two elements. The first element's hydrogen. The second element is sulfur, a nonmetal. So the base name here is sulfur. We're going to add the prefix hydro and the suffix ic acid. So hydrosulfuric acid. Now, this is a little different. That UR stayed. When we had sulfur as an ion, it was sulfide, right? We lost the UR. And here we're not losing the UR. Again, not going to trick you on that, and phosphorus does the same thing. So a couple of examples. Name HF, aqueous. Well, the H tells us what? Hydrogen means it's an acid. And there's one other element, it's fluorine. And so this is hydrofluoric, UO. Yeah, saying U and I put an extra U in there. Hydrofluoric acid. Again, following that pattern, most compounds have two names, two words in their name. And again, we just did this. Okay, H2SE. Well, hydrogen and Se is selenium. So the name of this one, two elements, hydro, selenic acid. Now here's the question. Why are there 2 hydrogens on that one and only 1 on the hydrofluoric acid? Because selenium forms a 2- ion. Selenium is in the same group as sulfur and oxygen. And based on its position in the periodic table, krypton's 0, bromines -1, selenium's -2. And then we think of them as being ionic. That H+, we're going to need 2 of those to balance the charge. So that's why some of them are H2. H2S, H2SE. Any questions? So that was the binary acids, and then we have the oxyacids. So these are going to have those oxyanions with hydrogen. So this acid, HNO3, has the nitrate ion in it. So let's just cover up the H, and what's left? NO3. NO3 minus is nitrate ion. Here, H2SO3. If we cover up the H's, SO3, 2 minus is sulfite. This one has sulfate. The number of the hydrogen ions is going to depend on the charge of that oxyion. So sulfate has a -2 ion. -2 charge. We just talked about this with selenium. So to balance that -2 charge, it's got 2 hydrogens. Sulfite also has a -2 charge. So to balance it, it's got 2 hydrogens. Nitrate ion is only -1, so it only needs 1. So oxyacids, we'll just go with how your book explains it. Again, the oxyacids are being broken into 2 categories. We've got ites and ates. So what we're going to do is we're going to look at the anion, that polyatomic oxyanion that is present, and we're going to look at the ending of its name and see, does it end in ite or does it end in ate? If it ends in ite, we're going to change the base name of the oxyanion to us and throw the word acid on there. If it ends in ate, we're going to change it to ic. Let's see if I didn't write that down anywhere. I'll write it down here. So I have a silly sentence for this one too, because I like silly sentences. Rick ate him. Nice. Cannibalism? I don't know. Maybe Rick's a dog that ate another dog, or I don't know. Rick ate him before he could bite us. Now let's just fix this. Again, gotta misspell things a little bit. Ick and ate go together. If the oxyanion names ends in ate, you change the ending to ick. Rick ate, ick ate. Those 2 go together. Before he could bite us, ite and us go together. If the ending of the oxyanion ends in ite, then you change it to us. Okay? Ick and ate, ite and us. So Rick ate him before he could bite us, or you could think of, you ate something and said ick because it was nasty. But there's these 2 things. There's ick, ate, ite, and us, and you have to remember which ones they go with. So here's some of the common oxyacids. Losing my ability to speak. HNO2. So let's look at the formula for that. If we cover up the H, we've got NO2. What's the name of that? It's nitrite. So the acid, we change ite to us, and that's nitrous acid. Notice there's no hydro prefix. The hydro prefix is when there's just hydrogen and one other element. If there's oxygen in there, there's no hydro. So let's look at this guy down here, H2CO3. Cover up the hydrogens. What's left? CO3 is carbonate. You know that because you memorize it. Carbon 8. 8 gets changed to ic. This is carbonic acid. This guy, cover up the H. Oh my goodness, look at that. There's a typo on the table. Good grief. Get out my red pen. It's only one. Because see over here? C2H3O2 minus. Minus one charge. Only one hydrogen over there. Nobody's perfect. But you would think with the book. Anyway, that's acetate. You cover up the hydrogens in the red mark. That's acetate. Ends in 8. You change the 8 to ic. Acetic acid. You see how that works? Bless you. So let's name these guys. Ah, shoot, I went over one of these already. That's okay, because we're running out of time. HNO2. You look at the first letter, it's hydrogen. That tells you it's an acid. You look at what's left. Oh, there's 2 elements. Okay, this is not hydronitric acid or something like that. We're going to look at this guy right here, NO2. Oops, still red. NO2, and what is that name? Nitrite. Okay, that has a -1 charge. Nitrite ion. Rick ate him before he could bite us. Nitrous acid. Okay? Nitrous acid. This guy right here. The H tells us it's an acid. Cover up the H, what's left? More than one element. So we look at the name of that polyatomic oxyanion. ClO4 is perchlorate. Perchlorate. That's ClO4 minus 1. 8. Rick ate him. Ic 8. Okay, so perchlorate becomes perchloric. Perchloric acid. Any questions? The question is, can we leave yet? So here's kind of the big picture. Big picture nomenclature. Okay? Sometimes it's helpful to take a step back and look at that. So that's how everything's divided up. There's also a flow chart, which you may or may not find helpful, and we'll cover that later. That's kind of like a little thing stuck on the end of this chapter.